Yes. Are we starting?
Yes, yes. Sapnata, are we ready?
Yes, please.
Okay.
Please go.
Good evening, जय हिंद सबको. Welcome to Digital Nalanda. आज Mentor Speak में we are discussing about nuclear energy, उसके application और उसमें career opportunities के बारे में. और इस स्पेशल सेशन में हम जुड़ते हैं एक एक्सपर्ट से जो उस फील्ड में पारंगत होते हैं, उस फील्ड के एक्सपर्ट होते हैं. और इसी कड़ी में वी हैव विद अस मिस्टर चेतन सूर्यवंशी. इज अ मैकेनिकल डिजाइन इंजीनियर जो अभी बार्सिलोना स्पेन में इसी सेक्टर में काम कर रहे हैं. और वेलकम चेतन टू डिजिटल नालंदा. और
Thank you.
हमारे साथ यस एंड हमारे साथ ऑनलाइन जुड़े हुए लोग और यूट्यूब से जुड़े हुए लोग, इनको हम बता दें कि सेशन के आखिर में क्वेश्चन एंड आंसर सेशन होगा, जिसमें आप अपने सवाल पूछ सकते हैं लिखकर. और ऑनलाइन जो जुड़े वो हाथ ऊपर करके या लिखकर हमसे सवाल कर सकते हैं. सो ओवर टू यू चेतन.
Well, thank you, Shubhot bhai. Good evening, everyone. First of all, welcome to this special session about the nuclear energy. I want to thank Nalanda Academy for this opportunity to explain and to introduce you this topic, which is very uh, demanding these days. And then let's explore the opportunities or how to pursue the education and everything with this nuclear field. Okay, so me. So let me introduce myself, Chethan Suryavanshi. I'm from Mysore, Karnataka. So I have education, completed my bachelor's in aeronautical engineering, and then completed my master's in aerospace science and technology in Spain, in Barcelona. So I got an opportunity to work in BEML. My experience starts in 2015. I started to work in BEML in Mysore, uh, location in Mysore. And then during my working in BEML, I got opportunity to pursue my master's, and then I started my career in Nissan as a design and development engineer. And then I moved to the R&D department in Simsa Aerospace. So it was, and after that, I started my career in ATG Europe, which provides support for the fusion technology, the nuclear fusion technology and uh, energy department. Okay, this is my brief introduction. So, as you all know, we will be talking about energy. So one thing I want to mention here is this is not limited only for the engineers. So this is a very introductive course or the session which will be applicable for all the domain people, irrespective of science and technology background. So any person who is in the management, who is in the commerce sector, who is in the other field, for them it's prepare it to be easy and applicable for them. Okay, so we will be talking more about energy and energy sectors, how it's functioning and what's the demands. Okay, the things what we'll be touching today is the global picture of the energy, the Indian government bodies, what are the bodies involved in this energy sector, and nuclear science history. And coming to the nuclear energy, we'll talk about the fission technology and the fusion technology and the Department of Atomic Energy, the education related to the nuclear sector, and some add-on courses to that, or the one you have already, and some job opportunities, and what are the recent updates in nuclear field, what's happening, and some challenges and some concerns. So during this session, if you have any questions, if you have any questions related to the topic or apart from this, please note it down so that I can answer you at the end. So let's see about the global picture of the energy, what's happening. So as you all know, the industrial growth has been increasing. So the developing nations, a lot of developing nations are consuming more energy for manufacture and to fulfill the demand, and also the urbanization is consuming a lot of energy. So the share of fossil fuels in the global energy mix has been declined. Also, we are seeing this another scenario where it has declined to a certain percentage, which was very high. And then the 40% of this the energy sector these days are produced by green energy, what they call green energy. With the advancement in technologies, the increased dependency on the electric vehicle or AI or all the gadgets what we use, or all the things what we use in daily life, this has made us increase in the demand of the energy. Also, the population growth, which has added more to this. So more people require more energy for homes or transportation or daily life, what I said. So as you can see in the graph, uh, the increase in the demand or the fulfillment of the energy from the energy sector, how it has increased from 1950. You can see here the different types of raw materials or the sources where they used to create energy, for example, oil, natural gas, coal, or clean energy, which is wind energy, solar energy, nuclear energy, how the demand has been increasing and how the clean energy is spiking up. So what the data I have here is until 2023. So until 2023, the points I've mentioned, that the advancement and the technology and the population which has added for this to create more energy, especially uh, the clean energy demand is increasing, and it's also the contribution of clean energy. What I mentioned, the 40% of the demand is met by clean energy. It's increasing. So in 2023 it was here, and in 2050, if we see, it's the most increased one. So what I mean to say is the future, the world is looking forward in the clean energy, the investment in the clean energy, the research and development in the clean energy. And one among the clean energy topic is nuclear energy, which we will be speaking in, we'll be seeing in coming slides. Okay. Okay. Next, let's see some uh, top 10 companies who are globally contributing, I mean, who are listed in the top 10. So here we know some companies. I think I'm sure some of the companies you have heard some companies, and some companies might be new because they are from different countries, of course. So GE, Siemens, Mitsubishi, EDF, one of the biggest players contributing to the energy sector. A lot of contributions are there. And when we see in India also there are a lot of giants contributing to the energy sector. For example, Tata Power, JSW Energy, Adani Renewables, NHPC, which is the government body, uh, and many more. So here I'm trying to explain you that what are the companies and right now are working with other clean energies like wind energy, hydro energy, or the solar energy. We'll be focusing more on in the nuclear sector side because of the advantages and the benefits it has, also counting the risk factors and the challenges what they have. Okay. Let's see some Indian government bodies. What are the government bodies which are regulating, making some terms and conditions, and giving some laws and the boundaries which in the within the boundaries the industries, the nuclear industries has to establish, and they regulate and they check from time to time. So these are the government bodies. There are a lot of government bodies which contribute to the Indian nuclear sector. Okay. So I have listed down some, like for example, Central Pollution Control Board. Of course, the main it's a statutory organization under the Ministry of India. that monitors and regulates air, water, soil pollutions, and it sets a standard for the emission of the pollutions or the any carbon or other poisonous element to the atmosphere. Okay, and it has implemented air prevention control and pollution act 1981. And then you can see the BEE, Bureau of Energy Efficiency, and it's another government body under the Ministry of Power that promotes energy efficiency and conservation. And it sets the standards and labeling program, and it promotes energy efficient appliances to the Indian society. And then you can see the Ministry of New and Renewable Energy. So this department promotes the adaptation of renewable energy sources, irrespective of solar, wind, hydro, nuclear, to reduce the reliance or dependency on the fossil fuel, of course, because it emits a lot of carbon dioxide and carbon particles to the atmosphere. And there is another important one, which is a Department of Atomic Energy. This government body is a commission or organization which is established by Indian government, which keeps track and which regulates the nuclear industries. And there are other bodies like Ministry of Power, Ministry of Petroleum and Natural Gas, and all these things. State electricity regulatory commissions, which is comes under the every state's whatever state you belong to. So apart from this, there are a lot of government bodies and public bodies which is contributing to the energy sector of India and also to the global side. Okay. So let's see some before we start more about the nuclear energy side. Let's see some nuclear. What was the history of this nuclear science? So in 1896, Henry Becquerel he discovers radioactivity. So he made a groundbreaking discovery that laid the foundation for modern nuclear science, the radioactivity. While investigating the properties of uranium salts, so Mr. Henry accidentally discovered these materials emitted invisible rays which are capable of penetrating opaque objects. Yani it can penetrate any opaque objects, irrespective of anything. So this phenomena was, which he termed as spontaneous emission, marked the first observation of natural radioactivity, and followed by whatever happened. It was a breakthrough in the science using the nuclear this radioactivity topic. And then in 1932, discovery of neutron by James Chadwick, which became fundamental to nuclear fission technology. And then in 1942, we see a breakthrough in energy sector. The first controlled nuclear chain reaction was achieved. Followed by also in the medical field, how important this nuclear science became. So, like you all know, the Marie Curie and Pierre Curie. We have been taught in school about this lady Marie Curie, who used the nuclear science in medical field to treat the cancer radiotherapy. It's also used in industry and agriculture to use these radioactive isotopes for non-destructive testings, inspecting welding, joints, and pipelines and other things. It's also used in space exploration. So the use of radioisotopes, thermoelectric generators to power spacecraft. So there are many more new application being developed in 2025. What we are here, we are seeing in future, there will be many more applications in different field. When we are seeing when it has when it's giving contribution to the field of medicine, space, agriculture, means it has a very huge. It has touched a very huge different sectors, and the application is very vast. Okay. Okay. And then let's see what is the history of uh, the nuclear science happened in India. So as you can see, he's a Homi Jahangir Baba, who is also known as father of nuclear science in India, because he laid a very strong foundation to the nuclear sector in India. So Homi Jahangir Baba in 1944, he laid a foundation for the Tata Institute, and in 1948, the Atomic Energy Commission was established to oversee India's nuclear program. So what I was telling about the government bodies, AEC is also one among the government body of India, and the Department of Atomic Energy was established in 1956 to first research. The reactor was Apsara, became operational under the vigilance of Department of Atomic Energy. And India conducted its first peaceful nuclear explosion, Pokhran, showcasing its nuclear capabilities because the world was looking forward who are involved in this nuclear projects, and also India was one of the country which were advancing in this nuclear sector to have energy using this nuclear fission or fusion technology. Okay. And in 1992, Pokhran 2 nuclear test established in India as a nuclear weapon state. Another test was performed. And then in 2000, expansion of nuclear power plants and international collaborations, what we have right now with Russia and other countries. And in 2024, last year, Indian government has also announced that the thorium-based reactors, renewable integration, and achieving net zero emission by 2070. So India is also working a lot to see the zero carbon energy. And another point we need to note here is India has approximately 25% of the world's thorium reserves. This means India is planning to use this thorium as a fuel, nuclear fuel, to achieve energy what we need. Okay, so this was one of the history of the India, or how the nuclear uh, energy started in India, and thanks to Homi Jahangir Baba. So nuclear energy. So, nuclear energy is energy released. So, when we say what is nuclear energy, is the energy released during the nuclear reaction, either through the fission or through the fusion. So, when you combine two atoms, or when you separate two atoms, or separate one atom into multiple atoms. So, this energy comes from the conversion of small amount of mass into energy. Also, we use Einstein equation E is equal to mc squared. So as you can see here, when uranium, an atom, is bombarded with a neutron, it releases energy with also some other atoms. And it's called, when you bombard one atom with a neutron, this is fission, because it continues with the chain reaction. Once the neutron hits the uranium, again it reproduces this chain. And then when we see the nuclear fusion, this is the fusion which is happening in the sun right now. So if we see the core of the sun, there is a nuclear fusion. That's how the concept started to be uh, getting interested. So in the nuclear fusion, it's opposite of fission. When the two atoms are fused at certain degrees Celsius with some factors like heat and with a vacuum and everything, there is a fusion. So when you fuse these two elements, you have an enormous amount of energy released. Again, with these two technology, it comes a lot of challenges to achieve this fusion technology or fusion technology. It has a lot of challenges, but the all the countries, or India is also focusing more on how to overcome these challenges, and thanks to the technology, the research and development, we have been able to produce certain amount of energy from this fusion technology. Because right now what we have is this technology. What's happening in India is with this technology. What we are seeing here, this is very futuristic, and this will happen. I mean, there are a lot of theories, there are a lot of experiments, but this the nuclear fusion, the energy what we get from nuclear fusion is way future. Okay. And let's see how this fission technology work, and also fusion, of course. So I got some schematic diagram here, which helps to explain you how the fission technology works. As I explained in my previous slide, we have the uranium as a fuel. You can also consider thorium, what I mentioned. So it is put here as a fuel rod, the core, which is a fuel rod, which will be in the rod. The shape of this fuel will be in the rod. And then there is a moderator, which is a water. You can use a light water or a hard water. Usually, the hard water is the very stereotypic thing what we use in the nuclear industry right now. But the light water is the one which is the advanced one. And then when this chain reaction happens here, the moderator, and there will be also control rods. The graphites are used as a control rod because this nuclear fission is a very fast reaction, and it's a very when it reacts, it liberates a lot of energy, and this energy is turned into be the heat energy. Okay, and then this is preserved in the pressure vessel, and all this water, the hot water, the moderator itself is a water. Okay, it is been built like this, which will be in pressure vessel, and the hot water passes here, and then this hot water, the steam which is produced with this hot water runs the turbine. There will be an enormous turbine in all the nuclear industries, which will be run with the steam. And when this heat energy is converted into electric energy, these with the turbine, they convert this in with the use of turbine, and then it's sent to the transmission line or to the electrical grid. And what happens with the water? Again, the water will be recirculated with the water pumps and sent to the nuclear reactor, where it will be again used as a moderator. And then I think if you have seen any nuclear reactor in Karnataka, Maharashtra, or in Tamil Nadu, you'll see a huge chimney here. This huge chimney, you will be seeing a smoke going on. So they have also built a chimney. So the smoke will be enormous. You can imagine how much electricity, how much the nuclear reactor will be producing, so much of energy, at the same time the smoke enormous. So here the water will be cooled down, and again it will be sent back for the circulation, used as a moderator. So this is a small schematic diagram for you to understand the fission technology. So if the fission happens here, where the chain reaction, the water gets heated, and the heated water will be turned into steam, and then the steam rotates the turbine, and that's how the electricity is generated. Okay. So, but this is a very simple explanation, but it involves a lot of engineering, a lot of construction things, a lot of management things, a lot of things. Okay. It's not so as easy as you see, but it's very easy, simple to make you understand what is fission technology. Okay. This is fusion technology. I'm sorry, this I have written fission. Sorry. But this is a fusion technology. In the fusion technology, as I explained before, when the two atoms or two elements are combined together at certain degrees Celsius. So, for example, when two atoms are combined together at the temperature of 150 million degrees Celsius or 300 million degrees Celsius, which is 5 times more the temperature of core of the sun. In this temperature, when two elements are fused, it liberates a lot of energy. And this energy is again converted as a heat energy, is converted into steam. As you can see here, the plasma, the fourth state of matter is plasma. That's what I said, what's happening in the sun. In the sun, there is a plasma. So that's what here in the fusion technology trying to create a plasma. And then we introduced deuterium and tritium inside the plasma. So it gets fused. And then the neutron hits the wall. When it hits the wall, the heat energy will be transmitted to the blanket. Here you can see the water, and the water will be sent to the heat exchanger. And here it creates the steam, and then the turbine works and the electric power is generated. And again, the water is condensed here, and again, it will be sent back to the same loop here. So, as you saw before, the fission technology, how it works, and the fusion technology, how it works, it has its own challenge because creating 150 million degrees Celsius is not a easy task. Okay, it needs a lot of equipments. It needs a lot of manpower. It needs a lot of engineer management. Again, a lot of people, technicians, operators. I mean, it's a huge. Okay, it's not as easy as we see, but schematically, this is how it works. So plasma, generate the plasma first, introduce deuterium and tritium, make them fuse. Neutrons are released, and that's how the when the neutrons hit the wall, the heat is created and the water takes the heat and then makes the steam, and that's how the steam runs this turbine, and that's how the electric power is generated. Okay. Okay, some examples of nuclear fusion technology. Okay, there are different types of fusion technology that adapt depending on their ideas or how they research and how they need, okay, how the country needs. So what we are seeing on the right side is called stellarator. Okay, the stellarator is one of the most complex vacuum vessel where you create the plasma. Here you can see this plasma, the pink, what we are seeing is a plasma, which the design of the stellarator, you can see it's very mm, it's very different. It's not so uniform. It has curves and edges wherever it needs. This means the plasma will not be having a uniform shape. It will be having the shape as per the vacuum vessel. But it's so complicated. This technology is very complicated. But still, the people are doing research and it's being built in America or around the world. As you can see, there are a lot of components needed to achieve this plasma. And this is huge. This is a very huge machine. And coming to the tokamak fusion reactor, this is also fusion technology where you can see 150 million degrees Celsius to 300 million degrees Celsius fusion is created in this vacuum chamber, and this is called tokamak. So tokamak is just like if you see a donut, it's a donut shape, or in if you go to South India, you see a vada which has a hole. It's just like this, the concept. But here in this technology, they create a plasma in this shape, and the neutrons or the elements like deuterium and tritium will be introduced and fused in this chamber, and energy will be released. Heat energy will be released. Okay, so this is what it's being built again in UK, Jet in France, and in Japan, in China, in Korea. So there are been companies, the governments have been working on this technology constantly from a long time. So there is a future with this. This is what the future of nuclear fusion depends on, with this kind of engineering and with this kind of technology. So I have also added here, if you need to know more information about the tokamak fusion reactor, you can see in this website, and also ITER India. ITER in India also, we have been working on this project, and you can get more information also in ITER India. Okay. So let's see about how the power production is now in the today's uh, time. Okay, so the nuclear power production by country, if we see, USA has more nuclear reactor now, and followed by China and France. And also India. So in India we have 22 nuclear reactor, and the amount of nuclear with this reactor, the energy what we produce is a lot. Like for example, India produces around 40,374 gigawatt per hour. Okay. And when we see the where are this nuclear reactor located in India? So there are two in Tamil Nadu, one in Karnataka, one in Maharashtra, and these are the power plants. But inside the power plants, you will be having a lot of nuclear reactors. And in UP, in Rajasthan, in Gujarat, so there are seven operational plants and 22 operational nuclear reactors with total installed capacity of approximately 7,480 megawatt electricity. So these reactors are managed by the NPCIL. Already, I showed you this the government bodies. This NPCIL is Nuclear Power Corporation of India Limited, is also one of the government body which regulates all these 22 nuclear reactors. Okay. And the good news is there are more nuclear reactor which is under constructions. So India has 10 reactor under construction with a total capacity of estimating to produce 800 megawatt electricity, which includes two types of reactors. Because again in the reactors there is different fission technology. There is a different types of reactors. Like PHWR is a pressured heavy water reactors, and VVER is Vodaioni energetic reactor. And the India targets in the year of 2031 to produce 22,480 megawatt electricity. So this means apart from these 10 reactors, India is foreseeing more reactors to have more energy from the nuclear technology. So um, it's growing. It's one of the fastest growing industry, I would say, and one of the industry which is sidelined by at least society thinking the nuclear might affect. It has a bad impact on human, so it has been sidelined. But there is a lot of money being poured in safety, security, and a lot of things, because of course the government there, and there are a lot of regulations and government bodies keeping an eye on nuclear reactors. So coming to the Department of Atomic Energy. So the Department of Atomic Energy is one of the main body which was created under the direct in charge of Prime Minister in 1954. So this acts as one of the governing bodies of all these nuclear reactors, and people has to and these companies has to give them all the details and to have the approval from DAE to have these nuclear reactors and to produce the energy using the nuclear technologies. So there is a lot of research and development been done under the Department of Atomic Energy, and a lot of companies are also under this Department of Atomic Energy, and it's contributing a lot for the nuclear energy. So coming to the education, so what it needs to be, what you need, the qualities to work in nuclear sector. I mean, there is no constraint. You can the education qualification, the thing what you have now, you can use it, or else you can enhance it, you can upgrade it. um, I will explain you how. Okay. So the people who have industrial training like ITI diploma with SSLC and ITI, and with SSLC, ITI, and apprenticeship, and the people who have some PUC and industrial training and some technical courses and industrial training can also contribute in the nuclear field, can find a job in nuclear field. So when you have the industrial training to work as an operator, also to work as an apprenticeship, to do apprenticeship in nuclear sector. So this is also basic courses, and undergrads can also. There are bachelors in nuclear sector these days. in engineering, any engineering domain, mechanical, you name it, mechanical, computer science, electrical, nuclear, industrial engineering, bioengineering, fire engineering, chemical engineering, you name it, all the engineering sector can contribute to the nuclear energy sector. This is the beauty of this, which I also discovered very lately, 5, 6 years before. And also the management courses, as I mentioned before, can also be considered. Commerce, technical courses, graduate training, internships, all this counts during your bachelor's. And also there are, if you have a higher education, master's, PhD, postdoc, others, other higher education can also be considered. Also, you can do the nuclear, if you are focused on nuclear energy, you can do masters in nuclear energy, masters in renewable energy, masters in clean energy, and in PhDs you have a lot of options around the world. A lot of universities are now opening the PhD positions in renewable energy, nuclear energy, in fission technology, fusion technology, materials, a lot. It's a domain which has a lot of scope in these days, in coming days. Okay. So in education, what I want to say is, don't constrain yourself. Even if you have a basic ITI diploma, you can contribute in nuclear energy. You can find a job in nuclear energy. If you don't have, you can enhance. There is a lot of courses, a lot of materials online these days and free, so that you can learn about nuclear engineering and nuclear technology. Okay, let's see what are the courses also we can add on. So as I mentioned in my previous slide regarding the bachelor's, so Homi Baba National Institute, which has campus around Mumbai, Indore, Kolkata, Bhubaneswar, a lot you can see here. They have campuses, they have collaboration with different institutes and different bodies also, government bodies. So as you can see in Homi Baba National Institute, I was checking, there is an online course, and this online course which gives you an idea about nuclear technology, nuclear engineering, or the concepts what you want to learn, and it's free of cost, and you can access it freely. And probably, I'm not sure if you can also apply for certificates. Okay, so that's the one thing. And then, apart from this, Homi Baba National Institute, there are the other portals which offers online courses. Please look for it, and for sure you can match something, and then you can learn more about this nuclear thing. And online courses allows learners to study at their own pace. Of course, these online courses you can learn at your own pace, and provides access to world-class instructor and cutting-edge content in specialized areas like nuclear engineering, radiation, safety, project management, materials, and different domains in engineering, structural engineering, design, and everything. And there are many institutions in India which gives bachelor's, which provides masters also, in like Tata, IFR, Saha Institute, Homi Baba National Institute, and more. And also, if you see the online portal like Coursera, EDX, and IAEA, International Atomic Engineering Association, I think, yeah. IAEA is International Board, and NPTEL. Here you can see also the online courses, which gives you idea about nuclear technology. Okay. And also one more thing I wanted to mention here is, in case like if you are from a different domain, for example, as I explained you about my introduction, I was aeronautical. My studies was completely focused on aeronautical and aerospace, and then now I'm working in nuclear sector. So of course there will be a challenges for the transition, but what helps this transition is these online courses. Okay, to understand the concept, to understand the application, to enhance the skill. So if we do this, even in irrespective of any domain you belong to, you can achieve in getting a career or having a job position in nuclear sector. Okay. Apart from this online course, I have mentioned. Wait, sorry, a moment. Apart from this online course, there is also something called digital library. So the DEA offers this digital library. So I was checking this website and then I got to know there is free books, picture books, and patrikas, and what are the events happening, and technical books and annual reports. What's happening in India with the nuclear sector? If you can see this, you can download this, you can read this. It is available in different languages in Hindi and in Marathi also, I think. Yeah. So these kind of things are available these days from Indian government, DEA, the government body. So please have a look at this. You can also use this to enhance your knowledge, to know more about the mechanism, how it works, and what are the things which you are focusing on. Okay, and it's very good initiative done because it saves a lot of page and I mean the wood to create the pages and all these kind of things. And with these, what you can get is some job opportunities, of course. So if you know about the CERN, CERN is located in Switzerland. The CERN works on this nuclear technology. If you enhance the skill, you also have opportunity to work abroad, apart from India in CERN. So there are some job roles they are looking forward from different countries. Of course, they also welcome up job application from India, and you have different sector in civil engineering, in data science, which is computer science, international relations, which is again about the management and different background and materials and surface. So that's why I mentioned, irrespective of whatever the background you have, a little bit of additional courses, some online courses, some certifications, you can get inside the nuclear industry. So you have the job opportunities in the abroad as well. As I was explaining about the nuclear fusion, which is the futuristic of the um, futuristic project. So I was seeing about the ITER, which is India is one of the major contribution for the ITER project. Okay. And then the very recent news, the Prime Minister of India and the President of France, Macron and Modi, they visited the ITER together. This is the ITER, which is the organization which works on nuclear fusion technology. So there are a lot of engineers, operators, and other people who are contributing to this technology. I would say more than 45,000 people. So the one project has created 45,000 job opportunities, what I mean to say. And India is also one of the big contributors to the ITER project. And we have inside India, it's called ITER India. So I have provided some websites here. You can check ITER India, what they are working. So they are also calling for PhDs, postdocs, and other, they also have some events scheduled. So this happened very recently on 12th of Feb. Prime Minister of Modi visited the project, appreciated, and there was a talks that the conversation that also news that India will advance more in the nuclear sector, and there are more updates coming for you people now. Let's see more. Okay, and also there is what I explained about this government body before, Bureau of Energy Efficiency. So there is a lot of also require recruitment and job opportunities in this Bureau of Energy Efficiency, which is a government body. Okay, so that's what I was trying to explain here. And as per our the previous month. one of the previous month news, the nuclear power in Union Budget 2025-2026. So the government is reserving amount or enhancing or increasing the budget for the nuclear energy project because they have a unit like 100 gigawatt nuclear power capacity by 2047. It's very futuristic. It's very ambitious. This means a lot of job creations and a lot of career uh, will be seen in coming years. Can see the growth of installed nuclear capacity in megawatt. In 2014, it was 4,780 megawatt, which is increased to 8,180 megawatt, almost double. So it's a good news, and this shows that how much India is interested in working in doing research in the nuclear industries. And India and France plan small modular reactor. So small modular reactor also has this nuclear fission technology where the reactor will be small and safe enough where it can produce a lot of energy, which we can power up more than 100,000 or 200,000 houses. Okay. And also you can see that NTPC plans to spend $62 billion on 30 gigawatt of nuclear power. So future is we are hoping a very good future with this nuclear energy and this nuclear technology. So these are the very recent updates. As you can see the dates, what I was checking, Feb 17th, Feb 16th. So this is what I thought, okay, let's give a session with this, which made motivated me to give start this session. And then you can see also the some opportunities, some how do you say internship opportunities or PhD opportunities. The recently what been published in ITER or other domestic agencies. So if you see, this was recent in the previous month. They're requesting students to participate in some activities, which is tuition fees and open to all nationalities, and it's provided in this portal. And there are also, so this in International Atomic Energy Agency, they're also providing online courses, and it's free. You need to register and you need to start the courses, and the courses you can complete. After the courses you will be having some certifications, uh, and yeah, please make use of it and you'll understand more about the nuclear technologies, the fission or fusion. Challenges. What are the challenges? I mean, of course, as I mentioned, it's a very vast, a very big domain. Um, it should be safe for the society and for the people, because already you have seen one of the disaster happened in India, the Bhopal gas tragedy. I mean, just in the air, how many people the chemical passed and how many people lost their life. Also, the radioactive element is also a bit very dangerous, and the waste management of this nuclear fusion or fusion technology is one of the challenging. But no worries, since the technology is being advanced, the people are trying to find different ways and different methodologies to confine this waste management. And also safety concern. There is a lot of safety concern. I mean, this is itself has a big domain inside the nuclear technology, because there's a lot of safety inspectors, safety people who work on the safety of this nuclear technology. And we have learned a lot of lessons from previous tragedies, what happened like Chernobyl and Fukushima accidents. And also what I have experienced also, like the France country has a lot of regulatory bodies and a good standard to build nuclear reactors. So there should be the government has, or the nuclear industry has to match these regulatories and accept these terms and conditions. Of course, it's also one of the challenges what the nuclear industry face these days. Mhm. So I think we are almost coming to the end. Yeah. So one of my quote here is think like a proton and stay positive, because even without being a chemist, most of the people know protons are positively charged. So when you think positive, your actions are always in the positive direction, giving rise to positive result. So don't ever belittle yourself or think negatively toward yourself. Stay positive like a proton and see how things work. And when I was preparing this session, I was just wanted to make this as a formula. Nalanda Academy plus nuclear fission or fusion methodology, which leads to a great energy, which is success. And that's true and evident what we are seeing with the students in Nalanda Academy right now. With a note of save energy at home, of course, we generate a lot of electricity and everything. Also, we need to save energy. Would request you to turn off your lights or laptop or computers if you're not using it. Please save energy. It's good. And thank you. And I wish you all the best for all the aspirants or for all the people who are looking forward to contribute in the field of nuclear energy or in the renewable energy sector. Because this session was completely focused on nuclear energy, which is one of the factor of clean energy, which is one of the means of clean energy. In the clean energy, there is also renewable energy, solar energy, and we can touch about this later on because I need to prepare for that. And then since this is my domain, I wanted to give you the essence of the nuclear energy, what's happening. So as you saw, a lot of updates were there, a lot of things were there, and feel free to ask any questions. So now we can make a Q&A. And before that, I want to also inform you that if you have not seen this, there is a web series called Rocket Boys. Okay, it's in Sony Live channel, and this web series is based on Homi Jahangir Baba, Vikram Sarabhai, and Abdul Kalam, and how they work, what are their contribution, what were the challenges Homi Jahangir Baba faced during his career or establishment of the nuclear energy in India. Okay, so on this note, I am gonna stop my my speech, my session. If you have any question, please feel free to talk or ask. Yeah.
Chetan, it was very insightful and great presentation. अ, हम जो छात्र हमसे जुड़े हैं वो हमने सवाल पूछ सकते हैं। उसके पहले
Yes,
मैं
please.
एक ब्रीफ में हिंदी में एक अगर अनुवाद कर दूं तो चेतन खुद एक इंजीनियर है और इन्होंने अपनी जर्नी जो है वो अलग फील्ड से एरोनॉटिक्स से होते हुए वो इस इंडस्ट्री में है। तो इस प्रेजेंटेशन का ये भी मकसद है कि ज़रूरी नहीं आपका न्यूक्लियर फील्ड से होना, एनर्जी फील्ड से होना ज़रूरी है। आप अलग फील्ड से भी आकर इस क्षेत्र में अलग अलग डिपार्टमेंट में आप ज़रूर काम कर सकते हैं। चेतन ने सबसे पहले न्यूक्लियर एनर्जी के बारे में हमको बताया, फिजन और फ्यूजन दोनों टाइप की जो वहाँ पर प्रोसेस होती है उस बारे में बताया। और हमें इतिहास बताया उन्होंने कि कैसे न्यूक्लियर साइंस का उगम हुआ और अब ये कौन सी लेवल पे आ चुका है और भारत इसमें कितना हद तक आगे बढ़ा हुआ है, ये भी चेतन ने हमको। भारत में भी इस पर रेगुलेटरी अथॉरिटीज है, इस पर रिसर्च इंस्टीट्यूशंस है, DIFR जैसे संस्थान है। और इसके अलावा यहाँ पर जुड़ने के लिए, यहाँ से जुड़ने के लिए जो एजुकेशन लगता है उस बारे में भी चेतन ने हमको बताया। इंजीनियरिंग के अलावा मैनेजमेंट फील्ड में, कॉमर्स फील्ड से टेक्निकल कोर्सेज करके, ITI जैसे कोर्सेज करके, डिप्लोमा करके, विभिन्न सर्टिफिकेशन कोर्सेज होते हैं वो करके, या कुछ लोग जो मास्टर्स या PhD या पोस्ट डॉक करते हैं अलग अलग विषयों में, वो ज़रूर इस इंडस्ट्री से जुड़ सकते हैं। जैसे कि बताया कि क्लीन एनर्जी का जो कंसेप्ट है जहाँ पर मिनिमम वेस्टेज या जिसको हम कहते हैं जीरो कार्बन एमिशन की बात होती है, उस क्षेत्र से जुड़ा ये सेक्टर है, और इसलिए ये बहुत पॉजिटिवली इसको देखा जाता है। और इसी के साथ साथ चेतन ने भारतीय स्टूडेंट्स के लिए एक होमी भाभा नेशनल इंस्टीट्यूट के बारे में बताया, जहाँ पे ऑनलाइन कोर्सेज भी है काफ़ी। और इसके अलावा TIFR साहा इंस्टीट्यूट और इस इंस्टीट्यूट में मास्टर्स और PhD लेवल के कोर्सेज हैं। शॉर्ट कोर्सेज NPTEL और IAEA की वेबसाइट पर आपको मिलेंगे। इसके अलावा अगर आप इंटरेस्टेड हैं तो डिपार्टमेंट ऑफ एटॉमिक एनर्जी की डिजिटल लाइब्रेरी में भी आप बहुत सी चीज़ें चेक कर सकते हैं। बहुत सी दुनिया भर में लैब्स हैं, जैसे सर्न लैब के बारे में बताया। और ऐसे ही जो बड़े प्रोजेक्ट्स हैं, इसमें ITER एक प्रोजेक्ट है, इसमें 7 देशों का या 7 मुल्कों का एक कंट्रीब्यूशन है, जिसमें भारत भी एक बड़ा कंट्रीब्यूटर है। उस बारे में चेतन ने हमें बताया। और भारत बहुत अग्रणी है, भारत बहुत आगे बढ़ रहा है न्यूक्लियर एनर्जी के क्षेत्र में। तो इसी आइटर जैसे एक संस्थान से ये बहुत अच्छे से हमको ज्ञात होता है। इसके बाद ब्यूरो ऑफ एनर्जी एफिशिएंसी में अलग अलग आपको जॉब अपॉर्चुनिटीज की भी बात चेतन ने बताई। और हम अब कहाँ है, जिस वजह से ये हमने सेशन भी करने की कोशिश की कि अभी न्यूक्लियर पावर के तरफ भारत भी बजटरी एलोकेशन डेडिकेटेड रूप से बढ़ा चुका है। और 100 गीगावाट्स कैपेसिटी 2047 तक की एक बेंचमार्क है जिस पर वो काम कर रहा है। और अभी भी हम देखते हैं 2014 में जो 47,080 मेगावाट हमारा था प्रोडक्शन, अभी हम 81,080 मेगावाट तक इस साल पहुंच चुके हैं। तो ये एक पॉजिटिव साइन दिख रहा है। और लगभग सभी ने NTPC, जबकि NTPC ने भी न्यूक्लियर जो छोटे वाले जो रिएक्टर है 30 गीगावाट्स का प्रोडक्शन के ऊपर उन्होंने भी अपना डेडिकेशन किया है, $62 बिलियन का। और इसके साथ ही मतलब ये जो इनिशिएटिव्स है, इससे हम देख सकते हैं कि भारत में इसकी डिमांड या इस क्षेत्र में डिमांड बढ़ने वाली है। इसी वजह से इस क्षेत्र में जो भी इंटरेस्ट लेना चाहते हैं, भले आप किसी भी फील्ड से हो, आप अपने अपने लेवल से जुड़ के आप कोशिश करते हैं। इंटरनेशनल कोर्सेज के बारे में बताया, जो न्यूक्लियर सेफगार्ड पॉलिसी इस बारे में और इंफॉर्मेशन एनालिसिस कोर्स है, इस बारे में भी चेतन ने बताया। तो ये जरूरी नहीं कि इंजीनियरिंग करें, ये कोई बेसिक ग्रेजुएट ही ये कोर्स कर सकता है। और बाद में न्यूक्लियर एनर्जी के चैलेंजेस के बारे में बताया, जो कि हमको ज्ञात है वेस्ट मैनेजमेंट को लेकर या डिजास्टर्स को लेकर। लेकिन जिस तरह का एडवांसमेंट हो रहा है, जिस तरह के अब हम AI जैसी टेक्नोलॉजी से जुड़े हैं, तो हम देख रहे हैं कि भविष्य में ये भी हम कर्व कर पाएंगे और इस किस्म की जो डिजास्टर्स हैं इससे हम बच पाएंगे। और ये एक मैं जिस्ट में बताया है, वैसे इन्होंने बहुत वास्टली डिस्कस किया है। तो इसके साथ ही अगर आपके कुछ सवालात हैं चेतन को, या इस फील्ड के ऊपर में कुछ आपको जानना है, या अपने खुद उसमें इंटरेस्टेड रखते, खुद क्या कर सकते कंट्रीब्यूट, इस बारे में पूछ रहे हैं, तो आप जरूर पूछ सकते हैं। और यूट्यूब पे जुड़े हमारे स्टूडेंट, दे कैन ऑल्सो राइट देयर क्वेश्चन इन द लाइव चैट बॉक्स। यस।
Yeah. I can see one question either in chat. It's by Pratiksha. So I see
यस।
it will good enough to hear ahead as you begin your presentation. In any way, I'm not aware the content. Okay. The content was very introductive, was very brief on the nuclear energy. Okay. Would be eager to know about your trajectory from mechanical engineering to nuclear science. Yes, as I explained you, the trajectory would be first to know what concept of nuclear technologies like fission and fusion. Okay, right now India is very focused on fission. Even the small modular reactor will be fission. and also doing some research with the fusion. Okay, there are two sides. So you can focus on fission and also on the fusion. Uh, if you want to change the career, please take some. I would advise you to take some courses in what I mentioned, the online courses of the Homi Jahangir Baba Institute and uh, EA. Yeah, here also you have free courses. You need to add on and also enhance your CV with these courses, update your CV with these courses, or whatever you do this. Probably this might help for you. And since you mentioned engineering, mechanical engineer has it's a key to open multiple doors at the same time. Like you can go into aeronautical, nuclear, automobile, renewable, a lot of things. Among that, nuclear science is also one. So you just need to enhance with some online courses. And if you have done some internships, you will be understand. And it will be great to know a bit more about the contamination and remediation aspects of the nuclear waste. Of course, this radiative water has to be stored somewhere, or it has to be cleaned. For me, what I understood is it will be recycled. It will be all these radioactive elements will be separated with this water, and again it will be recirculated. One thing, or else it will be if you see, for example, what's happening in Japan, in the Fukushima. So they clean the water, and this water is let outside to the ocean or the sea, nearby the sea. And also the government body check this water if it's portable or not. I mean, they have advanced at such a level that this moderator water or this nuclear waste is no more waste mm, to the atmosphere or to the other living beings, let's say. And it itself, nuclear waste itself is a very big domain. Okay, and probably if people are more interested with a detailed information, we can make another course, or another session on this, and then we can see what we can put on the table with the different topics, how it's managed, what are the future, and all this kind of thing. Because from the start, you're talking about the last part, is the nuclear waste management. The start, from start to the end, there is a lot of information. So if we can put all together, we can find we can connect to the dots, and we can find some opportunities in nuclear waste. But it's a good domain. I mean, it's a good topic also, the nuclear waste. And thank you for this question. Yeah. And do we have more question, Shubham bhai?
No, not on the online chat
Mhm.
box. Let me check chat box. One question, Chetan, from my side. You said that India has a larger thorium base, but our reactors are not actually thorium based. So why is it taking so much time, like build a thorium based reactor or working on it? Basically?
So I think replacing uranium or plutonium, which is the fuel, with the thorium, using this fuel is I think it's a very different types of fuel which needs a different chain reaction, which took some time to do some research and to implement this. So I don't know much of detail, but what I know now is the upcoming reactors they will be using thorium as a fuel. Yeah, and they replace uranium. Yeah. So far, I don't know why they were not using.
It will also result in cost cutting also, because we had to get the uranium from other
Yes,
countries.
exactly.
So
Yeah. Yeah, yeah, yeah.
you mentioned about Mr. Abdul Kalam. He also suggested once in his speech about more dependency on thorium for
Yeah.
future nuclear
Yeah.
energy
So I mean,
generation.
it's not very straightforward with these elements. Okay. because these are very radioactive elements. I mean, the energy released by these will be enormous. So it has to be studied first and then implemented. And it has to be checked if it's safe, if it's good for the environment and everything, no? So that's the reason it took a lot of time. Yeah. But nevertheless, we should be happy that now it's been implemented. I mean, also there is a job. I mean, the when I was preparing all the slides, I was seeing the opportunities in every slide. Okay, for me, probably it might be like that, but if you see from the government bodies to the end of the ether or in the sun, you have all everywhere you have opportunities. Yeah.
So somebody has raised hand. Uh,
Yes, please. Maybe you can unmute the person, no?
yes,
Hello.
Pratiksha. Yeah.
Hi. आवाज आ रहा है clearly?
Yes.
Okay. हाँ. So मैं ये कह रही थी like since it was about thorium reactors and India में recently uranium deposits have also been noted, right? But they are like too low grade uranium deposits. So that's a great thing कि हमारे पास एक asset आ गया. But विथ न्यूक्लियर रिएक्टर्स जो ग्लोबल लेवल पे अगर हम बात करें बिकॉज आपका एक्सपोजर स्पेन में रहा है
Mhm.
कैन यू टेल अस अ लिटिल बिट मोर अबाउट डिफरेंट रिएक्टर्स जो अभी एडवांस में किस तरह से अलग है और पास्ट में कैसे अलग थे अगर in your slides you have mentioned about Chernobyl, Fukushima, obviously इनकी reactor designs, the reactor rods, उनका component, the use of graphite replaced by some other elements. So, what is
Yeah.
this advancement, and on what aspects can a country, afford to have advanced nuclear power plants? और शायद इसी बेसिस पे फिर जो न्यूक्लियर वेस्ट की हम एस्पेक्ट देखते हैं जैसे लो लेवल वेस्ट है जिसमें हैंड ग्लव्स और छोटा मोटा चीज आ जाता है देन वी टॉक अबाउट द मीडियम लेवल वेस्ट जिसमें स्पेंट फ्यूल एंड देन द हायर लेवल जैसे वाटर जिसको तो एक बार रेडियो एक्टिव हो गया उसको तो कंप्लीटली वी गो फॉर लाइक कॉन्क्रीटाइजेशन एंड थिंग लाइक जो फिनलैंड में जैसे रिपोजिटरी उन लोग कर रहे हैं so in what way what do you see can India develop on या फिर what is Spain up to or yeah something like that if you can tell.
I would say, globally speaking, most of the countries are looking forward to achieve nuclear energy in their own countries. Okay, especially the France. In Spain, we have less reactor. It was there before. There are some closed, and still the world is using fission technology, which means hitting an atom with a neutron. Okay, this is the fission technology which makes the chain reaction. So right now, using the fission technology, France, Spain, India, USA, all these countries, they're producing the electricity. The futuristic will be two things. One, small module reactor. The small module reactor, there is a lot of research have been done, experiments have been done, and there is a hope that the small module reactor using fission technology again. Probably now it's time to use thorium. Maybe they are doing some research. I'm not so much informed with this topic, but at least the articles or the news what I see, I understood that small module reactor is the futuristic in India and also around the world because it occupies less space, and when it's more safe and it's when the safety is good, it can provide energy to a lot of houses and industries. And another futuristic is nuclear fusion, what I spoke about. So if you see in Japan, in Korea, in China, also the recent news, if you see in France, CEA, they have generated plasma. So the plasma is the most challenging part in the fusion technology. Okay. So when you create so much of the plasma with 150 degrees, 150 million degrees Celsius, or up to 300 million degrees Celsius, to hold the plasma is the most challenging thing, and more than fusing the atoms. I mean, you need to create the plasma and you need to hold it stable. So the fusion is also, there is a lot of people, as I explained, tons of people have been is been contributing, and people have already contributed. And science is leading us to this path. The research and the development is leading to this path also. There is a the TRL level is been increasing every year. If you see the technology readiness level, it's been like now 6 or 7, I think, with the fusion technology. And once this technology works very well, we can also generate a lot of energy with the fusion technology. So these two, for me, it looks very futuristic. And that's why I wanted to inform all the students that to focus more, let's not sideline the nuclear technology in the world of aeronautical, automobile, blah, 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 other departments. Let's also focus on the nuclear sector because it's getting boomed now. I hope I provided certain amount of answer for you, Pratiksha. Not completely, I believe. No, you are
कोई
muted.
और सवाल होंगे तो जरूर पूछिए। और अगर आप किसी भी विषय पर आप जानना चाहते हैं, इस फील्ड से जुड़े किसी भी विषय आपकी आप अपनी अगर पढ़ाई को लेकर पूछना चाहते हैं या उस फील्ड को लेकर पूछना चाहते हैं।
Chetan, you can also drop your email ID just in case if anyone wants to reach out to you.
In the chat, sir?
Yeah, in the chat.
Okay. Yes, sir. I have dropped my email ID. Also, I will put my LinkedIn links probably. Yeah. Sir, in case if students have more doubt, if you need another session, feel free. We can extend. We can make part 2 also. No problem.
Sure, sure. Yes.
Okay.
Chetan, one question from my side again. Like we are having we know about nuclear fusion, fission, and because we have been like we were science students, so we got interested in that. But there is a thing called buzz, creating a buzz about something or creating awareness about something. So the state or the government also releases certain advertisements, or even the schools are like addressed to like provide certain basic knowledge to the school students or the college students. So can there be an effort from this industry basically to reach out to the people through media or through school projects or through certain competition, science projects or poster competitions kind of thing, that could like encourage people from like very basic level, like from school levels or from graduation or 12th level, to like get engaged in this field, because we find that more of there is the awareness thing is very I mean crucial here, because once the information spreads over there, then only people get to reflect and react on it. So there used to be DAE advertisements in like during 90s, I guess, but I don't think there are some those kind of advertisements now, like public advertisements. So is there any chance or any such effort which is being provided uh, by the authorities, or is there any effort by our industry in that line?
Okay, yeah. Because I don't know how it was the scenario in 1980s or 1990s, but probably now there are certain government bodies which work under confidentiality. Okay, there is certain things which is very confidential, because now since technology advances, also different countries look forward to take some ideas or manpower itself. Okay, there is one thing called confidentiality. Probably they're focusing on that. That's the reason they're not promoting anything. Second thing comes on the interest, self-interest. Okay, you have interest, I have interest, people have interest. Okay, they have to do some follow-ups time to time. So in the atomic agency, the DAE or other bodies, in all the or also in Homi Jahangir Baba Institute, there is one column called events, news and events. So if we just click on this news and events, it will update us what happened before, what's coming up. So probably I would request if any nuclear technology enthusiast need to check with this what is upcoming, please go to this website and then explore this website. It takes hardly 20 minutes of your time and check what's coming up next with the events, because there are some opportunities which takes people from India to other countries to represent India or to learn new technologies. Like for example, I showed you recently in my slide that ITER was inviting, or the American, one of the American institute was inviting people from different countries to study or to pursue some training there. Yeah.
ओके ग्रेट चेतन, आपने हमें इतना समय दिया एंड ऑल्सो चेतन इज जॉइनिंग अस फ्रॉम बार्सिलोना स्पेन, तो उनका भी अपना लंच वगैरह साइड में रख के ही इज सिटिंग विद अस। तो अगले सवाल अगर आपके मन में उत्पन्न हो रहे हैं जो अभी आप नहीं लिख पा रहे, तो सर का ईमेल आईडी दिया हुआ है उस पर, सर को लिंक्डइन पर भी आप कनेक्ट कर सकते हैं, और इसके अलावा हमारी कम्युनिटी पेज पे यू कैन राइट योर क्वेश्चंस और एनी सच थिंग which you are curious about, you can ask him. And okay, Prayash, because it's like closing time, still he's asked, clean energy is not affordable for many people, he's asking.
No, I mean it's not something you buy in supermarket to be afforded. It's monitored and regulated by the government. I mean, we see of course now today the price of LPG increased 6 rupees, if I'm not mistaken. Okay, this 6 rupees will be studied and will be put up on the table upon a lot of meetings and a lot of things, and then okay, yeah. What if the nuclear energy is cheaper than the coal or the fossil fuels? I don't know. I mean, depends on the how it's monitored and regulated.
तो ये सेशन अपॉर्चुनिटीज और यहाँ पर न्यूक्लियर एनर्जी के सेक्टर में एजुकेशन को रिलेटेड रहा, और चेतन के बहुत बहुत शुक्रगुजार हैं। थैंक यू चेतन फॉर टेकिंग आउट टाइम फॉर अस एंड यू बीइंग part of Nalanda mentors, so you have been
I'm happy.
associated with, yes, so we are actually glad and to have you, एंड जो भी जुड़े हुए हमारे साथ अभी या फिर बाद में हमसे यूट्यूब पर जुड़ेंगे, उनके लिए वही हम कहेंगे, आपके क्वेश्चंस भी पुट करें, और साथ ही आप डिजिटल नालंदा से जुड़े रहेंगे, इसमें और भी हमसे मेंटर जुड़ेंगे, और आपके सवालात, आपकी क्यूरियोसिटी को हम जितना जितना हो सके हम सो थैंक यू अगेन चेतन।
Thank you, Jai Bhim.
Thank you, Chethan. Jai Bhim.
Thank you, sir. Jai Bhim, sir.
Thank you, everyone.
शुक्रिया सबका।
Thank you, Subodh.